Today's lesson is lines in the coordinate plane. This is lesson 3.6. Let's get into what we need for this lesson. You will need pencil and paper, graph paper, calculator, and a superior confidence and trust that the God who loves you can help you do all things that will bring him glory. Let's do the warm-up. Substitute the given values of m, x, and y into the equation y equals mx plus b and solve for b. Then, in 3 and 4, solve each equation for y. Go ahead and pause the video now. Number 1, the answer is b equals -6. 2, the answer is b equals 1. 3, the answer is y equals 6x plus 9. And 4, the answer is y equals 2x minus 4. Our objectives today, we want to graph lines and write their equations in slope-intercept and point-slope form. We also want to classify lines as parallel, intersecting, or coinciding. 2 new vocabulary terms, point-slope form and slope-intercept form. The equation of a line can be written in many different forms. The point-slope and the slope-intercept forms of a line are equivalent. Because the slope of a vertical line is undefined, these forms cannot be used to write the equation of a vertical line. Important note, if the slope of the line is undefined, you cannot use these forms to get the equation. Here are some forms of the line and some examples. The point-slope form of a line is y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a given point on the line. An example of this is y minus 3 equals 2 times x minus 4. The slope is 2, and the ordered pair x1, y1 is the ordered pair 3, 4. The slope-intercept form of a line is y equals mx plus b, where m is the slope of the line and b is the y-intercept. An example of this is y equals 3x plus 6, where m is equal to 3 and b is equal to 6. The equation of a horizontal line is always going to be y is equal to b, where b is the y-intercept. An example of this is y equals 2. Remember, a line with a y-intercept, b, contains the point or the ordered pair 0, b. It always goes through the axis, the y-axis, at 0, b. A line with an x-intercept, x-intercept a contains the point a, 0. Write the equation of each line in the given form. The line with slope 6 through 3, -4 in point-slope form. First, we write point-slope form. Y minus y1 equals m times x minus x1. Then we substitute 6 for the slope, 3 for x1, and -4 for y1. Now we simplify, and we get y plus 4 equals 6 times x minus 3. It's actually possible to look at this equation, y plus 4 equals 6 times x minus 3, and see the ordered pair and the slope all at the same time. Because it's x minus 3, take the opposite of minus 3 and get 3. Because it's y plus 4, take the opposite of 4 and get -4. So we know that the ordered pair goes through the point 3, -4. The 6 in front of the parentheses is the slope. So one of the benefits of having point-slope form is being able to look directly at the equation and see the ordered pair that the line goes through, as well as the slope. Write the equation of each line in the given form. The line through -1, 0 and 1, 2 in slope-intercept form. First, we need to find the slope. So, y2 minus y1 over x2 minus x1. This is 2 minus 0 in the numerator, divided by 1 minus -1 in the denominator. This gives us 2 over 2, which is a slope of 1. Now we use slope-intercept form, y equals mx plus b. Let's substitute 1 for the slope and -1 for x and 0 for y. Solve the following equation for b. We get b equals 1, which finally gives us the equation y equals x plus 1. Write the equation of each line in the given form. The line with the x-intercept 3 and y-intercept -5 in point-slope form. Find the slope. First, we take the slope y2 minus y1 over x2 minus x1. So we get -5 minus 0 in the numerator, 0 minus 3 in the denominator, which is -5 divided by -3. And since a negative divided by a negative is a positive, we get a positive 5/3 as the slope. Now we use point-slope form. Y minus y1 equals m times x minus x1. Substitute in 5/3 for the slope, 3 for x1, and 0 for y1. So we get y minus 0 is equal to 5/3 x minus 3. Again, looking at that point-slope form, we can see that this equation goes through the ordered pair, 3, 0, and the slope is 5/3. Simplify this equation, gives us y equals 5/3 x minus 3. Now you check it out. See if you can do this on your own. Write the equation of each line in the given form. Write the equation of the line with slope 0 through 4, 6 in slope-intercept form. Go ahead and pause the video now. First, use point-slope form. Y minus y1 equals m times x minus x1. Substitute 0 for m, 4 for x1, and 6 for y1. Y minus 6 equals 0 times x minus 4. But 0 times x minus 4 is the number 0, so just solve the equation for y and you'll get y equals 6. Go ahead and write the equation of each line in the given form. The line through -3, 2 and 1, 2 in point-slope form. Go ahead and pause the video now. Let's go ahead and find the slope. So m equals y2 minus y1 over x2 minus x1. So 2 minus 2 over 1 minus -3. This gives us 0 over 4, and 0 in the numerator means that we have 0 as the slope. Point-slope form would say y minus y1 equals m times x minus x1. Substitute 0 for m, 1 for x1, and 2 for y1. Y minus 2 equals 0 times x minus 1. Simplify, y minus 2 equals 0. Solve for y. So y equals 2. Graph each line. We have y equals 1/2 x plus 1. The equation is given in the slope-intercept form, with a slope of 1/2 and a y-intercept of 1. Plot the point 0, 1, and then rise 1 and run 2 to find another point. Draw the line containing the points. First, we plot the ordered pair 0, 1. Now, from this point, we rise up 1 and we run over 2. This now allows us to have 2 points, and it only takes 2 points to draw a line, so we draw the line through the 2 points. Graph each line. Y minus 3 equals -2 times x plus 4. The equation is given in point-slope form, with a slope of -2, which goes through the ordered pair -4, 3. Plot the point -4, 3, then drop down 2 and run 1 to find another point. Draw the line containing the 2 points. Graph each line. Y equals -3. The equation is given in the form of a horizontal line with y-intercept of -3. The equation tells you that the y-coordinates of every point on the line is -3. Draw the horizontal line through 0, -3. Now, since we have a slope of 0, we just acknowledge that 0 can be rewritten in a lot of different ways. 0 is the same thing as 0 over 2, which is 0 over negative 5, which is 0 over 3 pi. So it doesn't matter how much we run. The denominator doesn't matter. We can choose that willy-nilly as much as we like. There will be no rise because the numerator is 0. So I'm going to choose negative 5. I'm going to run negative 5 to the left. There is no rise. The rise is 0. And now I can draw the line going through the ordered pairs. And this is why y equals negative 3 is a horizontal line. Okay, you try it on your own. Graph each line. Y equals 2x minus 3. Go ahead and pause the video now. Okay, let's check it out. The equation is given in the slope-intercept form with a slope of 2 and a y-intercept of negative 3. Plot the point 0, negative 3, and then rise 2 and run 1. Just in case you're wondering, 2 is the same thing as 2 divided by 1. That's why we run 1. We found another point. Draw the line containing the points. Okay, try this one on your own. Graph each line. Y minus 1 equals negative 2/3 x plus 2. Go ahead and pause the video now. The equation is given in the point-slope form with a slope of negative 2/3 through the point negative 2, 1. So we plot the point negative 2, 1. And then we drop down 2 and run 3 to find another point. Draw the line containing the points. Okay, try this one on your own. Graph each line. X equals negative 3. Go ahead and pause the video now. The equation is given in neither form. This is a vertical line with undefined slope. Plot the point negative 3, 0, and then rise up or drop down any value you wish to plot another point. Since undefined means that we have any non-zero real number divided by the number 0, this means that we can rise or drop as much as we wish. So I plot the ordered pair negative 3, 0. I choose to drop down negative 3 because it doesn't matter how much I drop down. And this is the vertical line. There will be no run, so I draw the line through the points. This is why the slope that is undefined is always vertical. A system of two linear equations in two variables represents two lines. The lines can be parallel, intersecting, or coinciding. Lines that coincide are in actuality the same line, but the equations can be written in many different forms. An example of parallel lines: y equals 5x plus 8. Y equals 5x minus 4. Notice that both equations have the same slope, but different y-intercepts. This makes them parallel. An example of intersecting lines: y equals 2x minus 5. Y equals 4x plus 3. Notice that the slopes are different. This means that they will intersect. Coinciding: y equals 2x minus 4 and 2y equals 4x minus 8. In the second equation, all I have to do is solve for y by dividing everything by 2, and that would give me y equals 2x minus 4. So in actuality, we're looking at the same equation written two different ways. They both have the same slope, and they both have the same y-intercept. Therefore, they coincide. Example 3a. Let's graph each line. We have y equals 3x plus 7 and y equals negative 3x minus 4. The lines have different slopes, so they intersect. Graphing the two in a computer algebra system, I get the following situation. Determine whether the lines are parallel, intersect, or coincide. We have y equals negative 1/3 x plus 5, and we have 6y equals negative 2x plus 12. Solve the second equation for y to find the slope-intercept form. Divide everything by 6, and we get y equals negative 1/3 x plus 2. Both lines have a slope of negative 1/3, and yet the y-intercepts are different. This means that the lines are parallel. Graphing them in a computer algebra system, I get the following. Determine whether the lines are parallel, intersect, or coincide. We have 2y minus 4x equals 16, and y minus 10 equals 2 times x minus 1. This time we have to solve both equations for y to find the slope-intercept form. The first one, we add 4x to the right-hand side, and then divide everything by 2 to get y equals 2x plus 8. The second, we distribute the 2 into the quantity of x minus 1. Then add 10 to both sides, and we get the same equation, y equals 2x plus 8. Both lines have the same slope and the same y-intercept, so they are in actuality the same line, and they coincide. Try this on your own. Determine whether the lines are parallel, intersect, or coincide. Go ahead and pause the video now. Solve both equations for y to find the slope-intercept form. The first equation, what I do is I subtract 3x to the other side, then I divide everything by 5. This gives me y equals negative 3/5 x plus 2/5. In the second equation, what I do is I end up dividing everything by negative 5, which gives me negative 3/5 x minus 6 over 5 equals y, and then I use the symmetric property of equality. A equals b, so b must equal to a, so I can switch the y to the left and the rest to the right, and I get y equals negative 3/5 x minus 6/5. Well, the slopes are the same, but the intercepts are different, so therefore the lines are parallel. Erica is trying to decide between two car rental plans. Find the mileage when the plans become the same. So plan A, we know that she pays an initial fee of $100. In plan B, she pays an initial fee of $85. In plan A, the mileage fee is a rate. It's 35 cents per mile. And in plan B, the mileage fee is 50 cents per mile. The mileage fee is a rate, dollars per mile. This makes it a slope. For each mile traveled in Plan A, the cost goes up by 35 cents. The initial fee is a y-intercept. It is money that is paid up front before Erica gets the car. The form of the equation that best fits this scenario is the slope-intercept form of an equation. We know that Plan A cost is 35 cents times the number of miles plus 100. Plan B cost is 50 cents times the number of miles plus 85. This is the slope-intercept equation, y equals mx plus b. But we're not going to use y or x because we want to stay in context. We're talking about cost of different plans and mileage. So instead of using x's and y's, we use the variables Plan A cost, Plan B cost, and miles because it keeps the situation in context. We want to find the mileage when the two plans become the same. This means that both will cost the same. So in other words, we want to set the Plan A cost equal to the Plan B cost. By the substitution property of equality, this means that 0.35 miles plus 100 is 0.50 miles plus 85. We solve for the mileage, and we get miles equals 100. The cost for both plans becomes the same after 100 miles. Always finish your word problems with a contextual sentence. We graph both situations, and we see that they both meet at the ordered pair 100, 135. 100 is the mileage, and 135 is how much the plans will both cost at 100 miles. We can see very quickly from the red line, which is the bottom line, that the plan that has 50 cents per miles will eventually become more expensive after 100 miles has been traveled. Let's look back on this. Check your answer for each plan in the original problem. For 100 miles, Plan A costs 100 plus 35 cents times 100. Well, that's 100 plus 35, which is $135. Plan B costs $85 plus 50 cents per 100 miles. That's $85 plus $50, which is $135. So the plans cost the same at 100 miles. What if? Suppose the rate for Plan B was also 35 cents per mile. What would be true about the lines that represent the cost of each plan? The lines would be parallel because they have the same slope. Here's the lesson quiz. Go ahead and write the equation of each line in the given form, then graph each line. Go ahead and pause the video now. Number 1, y equals negative 2x plus 1. Number 2, y plus 1 equals 2/5 x minus 5. Here are the graphs of both lines. 3 and 4, determine whether the lines are parallel, intersect, or coincide. Go ahead and pause the video now. Number 3, they intersect. Number 4, they're parallel.
Praise Father, Son,